if you just apply this, that means what? Is less than or equal to C1 G1n plus C2 G2 of n, right? T1 is less than or equal to this, T2 is less than or equal to this, so sum of these two on the left hand side is less than or equal to sum of these two on the right hand side. As simple as that. Right? Now, we need to do some little trick here. So what is the trick we have to do? We have to define, we have to get rid of these two constants because we want one big move, right? So we want to get rid of these two constants and introduce only one constant. So let me introduce a constant C3, which is the maximum of C1 and C2. Okay, so let me introduce a new constant C3, which is the maximum of C1 and C2. So then now, once I introduce that, let me see. I can now replace them and say this is less than or equal to, so I am continuing from this line, right? This is less than or equal to some C3 times G1n plus C3 times G2 of n. Can I write that? Why? Instead of C1 and C2, I am just writing that as C3 times G1 plus C3 times G2. Why? Let's take up something. Always try to understand why it makes sense, okay? So what we had there, some C1 thing, right? So let's say we have say some 3n square plus 5n cubed. Alright? What I just did, my C1 and C2 here are what? 3 and 5. Right? So my C3 is going to be the maximum of C1 and C2. Right? So what's the maximum of 3 and 5, the two constants? 5. So can I write it as this is 5 less than or equal to 5n square plus 5n cubed? Because 3n squared is going to be less than or equal to 5n squared, right? Because 3 is less than 5. Right? So I'm finding the maximum of these two constants and just replacing the smaller constant with the larger one. You see that? We have 3n, this is our C1 G1 plus C2 G2, okay, right? So all I did was, I found the maximum of C1 and C2, which is C3. So C3 should be one of this, right? Like we have maximum of 3 and 5 is 5. So 5 is one among 3 and 5, right? So I can say this is what now? Just the maximum value between one. So instead of saying like this, maximum of C1 and C2, I am representing it as C3. Clear? Understood? Now, so it helps me to put these two together, right? So this is equal to what? Remember, I am not telling less than or equal to here because this is the same as this, because I am simplifying here. Right? I'm just taking the C3 out and say telling this is G1 of n plus G2 of n. So note that still this is not in the form we want. We want maximum of G1 comma G2. And we have a plus here. Right? So how to now get to that? Any idea? Can you use something similar technique? What is that we can do? Let's take out the same two functions. We have what there? 3n square plus 5n cube, right? Actually, you have now the inside term is only the function, right? So let's get rid of the constants if you want. So this is what? G1 is n square, G2 is n cube, right? Okay. Now again what? We are dealing with asymptotic notations, right? It means what? As n goes to infinity. As n grows to infinity, between the two, which one grows faster? N cube. So how can we say that? We can say n square plus n cube is always going to be less than or equal to 2 times the maximum of n square and n cube. Right? Why? Because you have a plus here. Right? So this is the most dominating of the two. At the worst, this may also be equal to n cube at the worst. Right? So we are adding n cube twice. This is 1 n cube, and at the worst case n squared put into n cube. Right? So when you add two things, this is what? Twice. Twice the maximum of what? N squared and n cube. Right? Because this is just an, okay, you have n squared and n cube, right? Between the two, the maximum is what? N cube. You know that. In general, G1, G2, maximum of G1 and G2. So that's why I wrote it like this. Okay? So, you are having one n cube term here, and at the worst case, this term could also be tending towards n cube, right? So, you are adding n cube plus an n cube, right? So, this will be less than or equal to what? N square plus n cube would be less than or equal to 2 times n cube. Isn't it? Right? Less than or equal to twice the maximum of these two. Same thing with numbers. Look at numbers. If you want to add 3 and 5, the sum will be what? Less than the maximum of 3 and 5. Sum of two numbers is less than the maximum of twice the maximum of the two numbers, right? Clear? Sum of two numbers is less than twice the maximum of two numbers. The two numbers are the same. That's why you have to have equal to sign. Clear? Okay? Likewise for functions, we have two functions of n, g1 and g2. So sum of the two functions would be less than or equal to what now? Twice the maximum of g1 of n and g2 of n. Yes or no? Two functions. You add them, the sum would be less than or equal to twice the maximum of the two. Right? Remember things like this. 3 plus 5 is always less than or equal to twice the maximum of 3 and 5. Similarly, for two functions, less than or equal to twice the maximum of the two functions. So these are two things you have to remember. This one and this one. Right? We get rid of C1 and C2, introduce C3. And then to get rid of the plus and introduce the maximum, we have to do something like this. Okay? So what can I say now? G1 plus G2 is what? G1 plus G2 is less than or equal to, now we have to introduce less than or equal to, right? So I'm writing the inner term. So C3 remains the same outside. G1 plus G1 of n plus G2 of n is what? Twice the maximum of G1n, G2n. Now this looks in the format we want. Why? It's all product, multiplication, right? So I can say, I can just rearrange this and write it as what? Can I erase this? You can rearrange this and just say what? Our T1 plus T2 is less than or equal to 2 times C3 and times the maximum of G1 of n, G2 of n. So why this is interesting? Because you can say C3 times 2 times this. I can just put 2 and C3 together. So this is some new constant, right? 2C3 times the maximum of G1, G2. Okay? So this is some new constant, say C prime or whatever, C4, whichever notation you want is fine, times the maximum of G1, G2. Of course, now we have to take care of our n. So here we had n greater than equal to n1, n greater than equal to n2. So let's introduce our n naught to be greater than or equal to the maximum of n1 and n2. Right? Because when you combine these two, the new constant for what? n0 should be greater than equal to the maximum of n1 and n2. So this holds good for what? N greater than or equal to n naught, which is basically the maximum of n1 and n2. So what does it mean? If you plot the graph, you understand what I did? I just combined the two constants, 2c3 as the new constant n4, and then for the two things n1 and n2, we have now the maximum of n1 and n2. Right? Like we did here, c3 is the maximum, c1, c2, likewise the n1, these two. Because this has to hold good for some n, right? This relationship t1 plus t2 is less than or equal to what? c4 times this has to hold good for some n greater than or equal to what? N greater than or equal to the maximum of n1 and n2. Where are those n1 and n2 coming? From what is given, because given thing is t1 of n is less than or equal to c1 g1 of n for n greater than or equal to n1, right? That's the definition. Similarly, t2 of n is less than or equal to c2 times g2 of n for n greater than or equal to n2. So t1 plus t2 is less than or equal to now a constant times the maximum g1 plus, not plus, comma g2, right? And this holds good for some n greater than or equal to what? The maximum of these two n values. Alright? If something is let's do like this, 3n square plus 3n cube plus 5n square, right? Did I have that? Or let's the other way, right? 3n square plus 5n cube. Let's say 3n square is greater than or equal to some big O of n cube for n greater than or equal to 3, just some numbers, arbitrary numbers, okay? 5n cube is greater than or equal to big O of n to the 4 for n greater than or equal to say 7, right? So now the sum of these two is greater than or equal to what? Twice the maximum of n to the cube and n to the 4, right? So if this is greater than or equal to, if this holds good for n greater than or equal to 3 and this holds good for n greater than or equal to 7, the sum of these two is guaranteed to hold good for what? N greater than or equal to maximum of 3 and 7, isn't it? If a function, this is true for n greater than 3, this is true for n greater than 7. The sum of these two is greater than the maximum of these two, and this is guaranteed for n greater than the maximum of 2 n 3 and 7. Right? Just visualize, draw the graph. You have n, you have, this is what? 3n squared, this is greater than, I don't have that many colors here, but let's see. This is say n cube, and this holds good for n greater than or equal to 3. And then we have a 5n cube. 5n cube is this, and this is greater than, should be more, right? So 5n cube is this, and this is greater than n to the power 4, right? And this holds true for what? N greater than or equal to 7. So when I combine these two, right? When I combine these two, 5n cube plus 3n square, right? Should be greater than what? N to the power 4, whatever the greatest of these two, because this one, the second, the red one is greater only after n greater than or equal to 7. The red one is not following this relationship for n less than 7. So the sum can be only greater than or equal to the maximum of this for only what? Guaranteed to be true only after what? N greater than or equal to the largest of the two, 3 and 7. Right? only after n greater than or equal to 7. Right? So the sum can be guaranteed only after this n value. So this is the maximum. Okay? Clear? This is a constant. You don't need to worry about it. So what we can write now this. We can write this as T1n plus T2n is what? Why we did all these things? Is equal to what? We go maximum of G1, G2. Right? This is by definition of big O, right? The whole thing can be one function. T1 of n plus T2 of n is some function of n. And this is less than or equal to some constant times another function. So the function itself is maximum of G1 and G2. So T1 plus T2 is big O of the whole thing. The whole thing is what? The maximum of G1 and G2. The whole thing is function. The maximum of, say, n squared, n cubed, the maximum of those two is n cubed. Right? Okay? Good. Any question? So try it as a practice. Actually, I have the slides too, but don't look at it right away. Do it on your own. How would you prove the same thing holds for theta? So you could use it for theta, but what is more interesting is for omega. What is the relationship for omega? If T1 of n is omega G1 of n, and T2 of n is omega G2 of n, can anyone say what is T1 of n plus T2 of n? Omega of the minimum of G1 and G2. Why? How is it true?
Because we can write it out and prove it.
So you know how to prove it?
I'm here to learn, sir.
You said you can write it and prove, so I thought you should have had something in mind to say this, right? So
Yeah.
what is that key thing you had in mind to come up with this?
T1n plus T2n is less than or greater than
Less than or greater than? Only one of the two.
I mean less than or equal to, I'm sorry.
Less than or equal to something like this, right?
Yeah.
Okay, this is less than. So in this case, it is greater than.
Okay, it's greater than for omega?
Because what is this by definition? T1 of n is greater than or equal to some constant times G1, right? Yes?
Yes.
T2 of n is some constant times G2, right?
Right.
Okay? So, and adding these two, this is going to be C1 G1 plus C2 G2, right?
Right.
So the same kind of treatment, the only thing is instead of maximum we have to introduce a minimum, because here we have greater than or equal to. So which means my C3 is going to be the minimum of C1 and C2, right? So if you have something like what? 3n squared plus 5n cubed, this is going to be greater than or equal to the minimum of the two is what? 3. So I can say 3n squared plus 3n cubed. So 3n squared plus 5n cubed is greater than or equal to, is greater than now, greater than or equal to 3n squared plus 3n cubed. Right?
Right.
So I can say T1 plus T2 is what?
It's greater than or equal to
C3
mean. Right.
C3 is a minimum, right? So this is C3 G1 plus C3 G2. Like I wrote 3n squared plus 3n cube, I can say C3 G1 plus C3 G2. Replace C1 and C2 by C3. So C3 G1 of n plus G2 of n. So now the same thing. If you have two functions, G1 of n plus G2 of n, right? The sum of the two has to be greater than or equal to what? Twice the minimum of the two. Like there, the sum of the two functions has to be less than or equal to twice the maximum of the two, whereas the sum of the two functions has to be greater than or equal to twice the minimum of the two. Is that clear? So let me write that step. So G1 of n plus G2 of n is greater than or equal to twice the minimum of G1 of n, G2 of n. The minimum. Right? So you want an example, n squared plus n cube. N squared plus n cube is going to be greater than twice the minimum of n squared and n cube. So you have two functions n squared and n cube. The sum of the two will be at least twice the minimum of the two. Can you visualize that? Same thing, like 3 plus 5. 3 plus 5 has to be greater than or equal to twice the minimum of 3 and 5. Okay? So now that helps me to simplify what? I can say T1 plus T2, T1 of n plus T2 of n is what? What we have here? Greater than or equal to C3 times twice the minimum of G1 and G2, right? So that is 2C3 times the minimum of G1 and G2, isn't it? So it is the format I want. This is a function of n. It is greater than or equal to some constant times the minimum of G1 and G2. So I can say what? What's the relationship between them? What's the omega? Big omega. T1 plus T2 is what? Is omega of what? Minimum of G1 and G2. That's all it is. Right? Right. So practice a couple of times, you should be able to prove both ways. For omega, for big O and theta, it's the same. So I'll ask you for big O like you did, and then now for omega. Okay? So it's a very important theorem. Like we basically what this theorem states. Just pick the dominating function. Like if you have n square, n cube plus 3n square plus 5n or something like this, just pick the most dominating function. Okay?
Yeah.
Well, in the case of omega, it is what? The least dominating, right? We want to look at omega as the least dominating. So we probably won't use omega beyond this chapter, so don't focus much on omega. We'll focus more on theta and big O, right? So we'll always use the most dominating term. Any question? Okay, so now let's do, having heard of this L'Hopital's rule. Yes. Okay, good. Do you remember what it is?
I remember it was in Cal 1, that's about it.
You took Cal 1 here?
Yeah.
Okay. So I have worked out all these things that I read on the board here, okay? So all the proofs are here.
Oh, you got it wrote down already?
Right, yeah.
It's a good practice. That's why I didn't show you. Otherwise, I thought you would take notes. So I wanted you to take notes. But still, if you miss something, it's out there. Okay? You see how much pain for me to write down and scan it and put it on the slides to help you out? Alright, L'Hopital's rule. You should know how to do limits. Did you know that? Okay. So the sign-up sheet is going around. Everyone should sign, otherwise you'll be in trouble. Again, sign means don't sign just like your name. So, and if you didn't get the syllabus, talk to me after the class, okay, if you missed the first class. Is Hakeem here? No? David Parker? Yeah, only those who are not here. Okay. Alright. Okay, let's do L'Hopital school. So if you have, the way we are going to do this is, given two functions, T1, T of n and G of n, you want to look at which grows faster compared to how T of n grows compared to G of n. Remember, you want to say T of n is big O of G of n or theta of G of n, something like that, right? So we are going to use this theorem to find out that, whether it is omega or theta or big O. Okay? So again, we should know all these things by now. Why? Because what does it mean if I say T of n is big O of G of n? By definition,